Hello students, my name is Ningudu and I'll be taking your mathematics. We'll discuss on chapter 1, that is a set. Basically, a set is a collection of things. By definition, we see that a set is a collection of well-defined objects which are distinct from each other. A set usually denoted by capital letter, that is A, B, C, and so on. And elements are usually denoted by a small letter, that is A, B, C, and so on. For example of the set is a set of natural number or a set of a integer. Those are the examples of the set. Now we're going to see some standard notation for set. First point is a set of natural number is denoted by n. A set of whole number is denoted by w. A set of integer is denoted by z. A set of positive and negative integer is denoted by z plus and z minus. A set of rational number is denoted by q. A set of positive and negative rational number is denoted by q plus and q minus. A set of real number is denoted by r. A set of all positive and negative real number is denoted by z plus and z minus. A set of all complex number is denoted by c. Now, if an element a is a set of a, then we can write as a belong to a. So this will be the sign for the symbol for the a belonging to a. If a does not belong to a, we can write as a does not belong to a. Now we're going to see the different types of set. The first point is empty set. A set with no element. So taking an example, say this will be the set with a set with no element, which means a set contains of zero element. Or in another way, we can write as this is called a null set. So for second point is a singleton set. A set with one element. That means a set consists of only one element. Say, example, finite set. A set with a limited elements, which means, example, say 1, 2, 3, and 4, which means the given elements can be countable. So these are the example for the finite set. And infinite set means, example, a set of natural number. A set of natural number, that is a natural number with 1, 2, until infinite, which can be uncountable number. So infinite set done. For the equal set, two sets are equal if they have same element. Say for example, a set A consists A, B, C, and D, and set B consists of element A, B, C, and D. Now we can see that A is equal to B. Equivalent set. A set having different element but have same number of elements. Say example, a set A consists of 1, 2, 3, and 4, and set B consists of A, B, C, and D. Now we see that A consists of total number is 4, and for set B consists of total number is 4. So by the definition, we see that a set having different elements but having a same number. So we can see that A is equivalent to B. Now we have universal set. a set containing all elements and which all other sets are subset. See, usually this symbol is denoted by a universal set symbol. Symbol for the universal set is this. So example say example universal set, a set containing an element that is 1, 2, 3, and 4. Set A contain 1, 3, and 4, and set B contain 2, 4, and 5. Since A is a proper subset of U or universal set U, or B is a proper subset of, that is, the given universal set U. Since we see that an element from A and element B we are found in the set given, that is a universal set that is U, so we can say that A and B are the proper subset of, that is U. So for the second is for the Aries subset, a set is a subset of a set A is a subset of B if and only if every element in A is also an element in B. Say, the notation for the subset is A subset of B. Example, a set contains of 1, 2, and 3. Now the possible set we can write as, say, for possible set we can write, 1 is 1, 2, 3. Possible set we can write as 1, 2, 1, 3, 2, 3, 1, 2, 3. So we can see that these all set are the proper subset of the given set A. So this is the example for the subset. So for the point 9, that is proper subset. So a set A is a proper subset of set B if there is at least one element in B not contained in A. That means symbol for the proper subset is A proper subset of B. Example, take a set contains of element 1, 2, 3, and 4, and B contain 1, 2, and 3. Thus, we can see that B is a proper subset of A. For the superset, a set contains all the elements of another set, which means for the symbol for the superset is A superset of B, which is the reverse of the subset. Now for the power set, a set of all the subset of A, which means for example, I'm taking a set consists of two elements, that is 1 and 2. Now we're going to see the proper subset. So I'm taking 1, 2, 1, and 2. So clearly we can see that the given set is the given set, that is set A, and the possible set we can see that 1, 2, and 1 set of 1 and single 2 set of 1 and 2. Those are the proper subset of set A. So except of all the subset of a set. So these are the power set. Now for the intervals, there are two types of interval, that is open interval and second one is closed interval. Now for the first point is open interval. A set of all real number lying between a and b is called an open interval, say, which this symbolically we define as a b open set x belong to a real number that is r from a interval of b, which means, say, I'm taking set A and set this is set B. A set contain all real number lying between A and B. So here we can see that all the point lies between A and B are included, but A the but A and B are does not belong to this interval, which means only these points are included. So we can say that A, B are the open interval. For the closed interval, a set of all real number lying between A and B, including A and B, is called a closed set, which means for the symbol of closed set, a closed interval, x belong to real number from A interval of B. So I'm taking which means the set of all real number lying between the set of all real number is real number lying between A and B. So the point lines between A and B are included, and even a set of A and B are also included. So this is the definition for the interval, that is open interval and the closed interval.